Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze a water bottle for its explicit dynamic analysis. We will see what happens when we apply an internal pressure on the water bottle. We will start by double-clicking on Explicit Dynamics module. First, we'll go to Engineering Data and double-click. Here we will go to Engineering Data Sources. We'll go to Explicit Dynamics option and double click here. We will analyze for two material. One is copper. So I will first bookmark copper. This one. And the other material which I'm going to use is stainless steel. This one. You can go to Engineering Data Sources again and you can see that these two have been selected. Then I'll go to Project and Update Project. Next I'll go to Geometry and right click. I'll import geometry of the bottle which is made with me. Then I'll go to Model and double click. I'll first go to geometry. Here there are two parts. I don't need the cap, so I will suppress this body. Then I'll go to the second one, that is the body, and I'll change the material first to copper. Then I'll go to mesh and I'm going to generate the default size of the mesh itself. So now you can see the mesh has been generated. This is a tetrahedron type of mesh. Next I'll go to Explicit Dynamics. First we'll go to Analysis Settings. Here the time was required, so I'll give 0.001 second. Then I'll go to this option, right click and insert Fix Support, which is at the bottom end. I'll click on Apply. Next on the top face over here, I'll select Face option. Here I will apply a force. So I'll right click, insert force, change vector to component. The direction is Y. So I'll apply a force of minus 50 Newton. Again I'll right click and insert pressure, this time on the internal surfaces. So let me select all the surfaces that are inside the bottle. So once I've selected all of them, I will click on Apply. Next I'll apply the pressure. First I'll apply a smaller value of pressure. So it is say 5 megapascal that I'm going to apply. So it is 2 megapascal that I'm applying. Now this is the normal pressure of water which is exerted on the bottles generally. So let's solve for this one and see. Next I'll go to Solution, insert deformation total. I will insert deformation directional along the x-axis. Also I'll insert deformation along the y-axis. Then I'll insert strain and stress. Then I'll go to Solution and Solve. Now the solution has been generated, so let's see the result. The first one is of total deformation. We can animate and see this result. You can see here that there is a deformation of 0.2 mm, which is actually a very small value. Hence, you are not seeing a significant change in the dimension here. The next one is directional deformation along the x-axis. Again, this is 0.1285. You can see the maximum value is here. If you want to see where it is minimum, it is somewhere here. So these are the values which you can see. Then you can go for directional deformation along the y-axis. Minimum is here, maximum is here. The maximum is 0.00115 and this is the minimum value. You can also animate and see this result. Then we'll go for the strain. The maximum strain is 0.00093 and minimum is 5.22 into 10 raised to minus 6. You can see where it is max and where it is min. Then we have the value of stress. Maximum is 117.24 megapascal, which is here. Minimum is at this end 0.5338. So this is all about the internal pressure which is creating effect on the bottle. Now next what I'll do is I am going to solve this for a pressure of 5 megapascal. So we go to pressure and here I'll select 5 megapascal and I'll solve once again. So we can see the result is generated. We'll go to total deformation first. You can see that there's quite an effect of the pressure on this water bottle. So it is showing a kind of bursting effect, though it is not breaking completely. So we can just animate and see this result. When you studied the same result using static structural, you will not see the complete bursting effect. You will only see the swelling effect like this because of the internal pressure. Now maybe it was not enough to burst the cylinder. So 5 megapascal has led to this result. Now the maximum deformation is 20.41 mm. You can see based on the color, and the minimum value is 0 over here because it is fixed. Then you have directional deformation along the x-axis, maximum being 16.766 mm. Along the y-axis, the maximum deformation is 0.21776 in this zone it is showing, and then the equivalent elastic strain is 0.00338. The stress is 412.27 megapascal. The stress is increased as compared to 2 megapascal result, and the minimum is 0.92632. You can see where it is minimum and maximum by clicking on max min. If you don't max min, just click on them once again. Now we will analyze this bottle for another pressure which is 7 megapascal, which is more than this. We will see if the bottle actually is going to break open completely. So we'll go to pressure. Here I'll change this value to 7 megapascal and I'll solve once again. So you can see the results have been obtained. We'll go to total deformation first. Before that, you can see beside solution there is a red thunder sign, and beside the solution information also there is a yellow thunder sign. Now I'll show you the reason why. When you click on total deformation, you can see there is a bursting effect. We will animate and see. It's creating a bursting effect and the bottle is going into pieces. You can see there is a breaking over here. Because of this, these signs have appeared. So this is the total deformation. Maximum value is 68.16 mm. Then we will see the directional deformation along the x-axis. Maximum value is 54.2 mm. Along the y-axis, the directional deformation is 0.54 mm. It is maximum along the x-axis, and then you can see equivalent elastic strain. The maximum value is 0.0035 and the maximum stress is 450 megapascal, which has again increased. You can see the entire body is under stress. Now if you increase the value of pressure more than 7 megapascal, then definitely you can see the bottle breaking into complete pieces. So now we are going to change the material to steel and we will see the results. We will change the material to stainless steel. We'll change the pressure to 2 megapascal. We'll go to solution and solve. So we have got the result. We will first go to total deformation. We'll animate and check the result. You can see there is no bursting with stainless steel at 2 megapascal. This is the general pressure applied by the water contained in the bottle. The maximum value of total deformation is 0.0619 mm. Then we'll go for directional deformation. Maximum value is 0.044 mm. Along the y-axis, the directional deformation maximum is 0.0273 mm. The elastic strain maximum is 0.00099, minimum is 5.13 into 10 raised to minus 6. You can click on max min, you will find out where it is maximum and where it is minimum. So we'll click on max min again if you don't want to see the options. Then we'll go to stress, maximum value is 183.91 megapascal. Now you can see when we apply 2 megapascal pressure internally on a steel bottle, this is the value of stress obtained, which is lesser as compared to copper bottle. So now we will go to the next pressure. You can check for 5 and 7 megapascal. I have got the bottle to be safe under these two pressures also. Also under 10 megapascal I have calculated the bottle is not going to burst. After calculating I figured out that at 20 megapascal when we solve we will get the value of bursting. So once we are done with the 2 megapascal pressure, we will change the pressure. We can also test for 5 and 7 megapascal like we have done for the copper bottle. I have tested it. The stainless steel bottle is safe under both the pressures. In fact, even if you go for 10 megapascal, the bottle is safe. So to show you the bursting of this bottle, I will analyze this for 20 megapascal. I have tested the bottle is going to burst at this pressure. So let's check with this pressure now. I'll show you the results. So we'll go to solution again and solve. So we have got the results. Let's go for the total deformation. You can see here. We'll animate and see the result. There is a total bursting of this water bottle under this pressure of 20 megapascal, which is obviously a very large value. And you can see the amount of deformation is 176.1 mm, which is 17.61 centimeter. So obviously there is a big deformation and there is a complete bursting of this water bottle. Next we will go for directional deformation along the x-axis. Maximum value is 151.22 mm. This will also show you the same sort of bursting and you can observe the color change which is taking place over this bottle. Next is the directional deformation along the y-axis. The maximum value is 81.692 mm. Then we'll go for the value of equivalent strain. The maximum is 0.0052 and the stress value is 1000 megapascal, which is obviously a very large value of stress. Because of the stress generated, the bottle has completely burst. You can see that this is a stainless steel bottle, so this has shown the maximum resistance and it has finally burst. Now I have checked between 10 megapascal and 20 megapascal. You can check for any value between 10 to 20 megapascal and possibly you will get the results for a lower value as well. But I have randomly checked for certain values and given you an analysis. So with this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.